Recall that a function defined as an integral gives the accumulation of a rate of change. So for example, if we integrate from some value a to some value x, in this case the accumulation function is g of x, so we have an accumulation from 2 to x that keeps increasing. Now if we integrate over a fixed interval, so say from a to b, then the integral of the rate function, or the rate of change of a quantity, gives the net change of that quantity over the interval. So effectively the area under the curve of the rate function gives the net change of that quantity from a to b. And typically the rate function f of x is going to be given in terms of time. So we want to integrate the rate of change of a quantity over a time interval, rather than in space. And in applied contexts, you'd be given a verbal problem, and you'll translate that into an accumulation or a net change. And we'll do that in the coming examples. The volume of oil in a container increases at a rate of v dash of t, and write the definite integral that gives the net change of the rate at which the volume increases between 2 and 6 seconds. So the change in the rate between 2 and 6 seconds can be written as follows, and that's thereby equal to the area under the rate of the rate curve. So basically you differentiate this function and then get the area under the curve by integrating from 2 to 6 seconds. And that's our integral. YouTube subscribers increase at a rate s dash of t per month between 2 and 6 months. And we're asked to write a definite integral that represents the total number of subscribers to date if there are 100 subscribers at the start of the second month. Well, the total subscribers at 6 months is equal to the initial number of subscribers at 2 months plus the total subscribers from 2 to 6 months. So to get that, we integrate the rate of change of the subscribers over time. A population grows at the given rate, and determine a total population after 5 years if the population is 100,000 at 2 years. And we can assume the following quantities for the rate constant and the initial population. So we're asked for the total population at 5 years, and we're given the population at 2 years. So we have 100,000, and then we add the population between 2 and 5 years. So that'll be the integral of the rate over time. So we take the constants outside, and we're integrating e to the kt with respect to time. And that gives you the area under the rate curve. And now you can evaluate this integral, substitute the required values, and post your answer in the comments. A particle's position changes at this rate, and determine the net change of the rate of its position between 3 and 7 seconds. Well, the net change in the rate is going to be x dash of 7 seconds minus the first derivative of position with respect to time evaluated at 3 seconds. So you can get this right away from the rate function or the velocity, or alternatively you can differentiate this to get the acceleration and then obtain the area under the acceleration time curve by integrating from 3 to 7 seconds, and that's going to give you the exact same result. So have a go at doing that and post your answer in the comments.